Well, hello, my name is Jesse Kelly. I'm the programming coordinator here at Chesterfield County Public Library. I'd like to thank Mad Science for offering this program this morning. I'd like to thank everyone for attending. And of course, I'd like to thank the Friends of Chesterfield County Public Library for making these programs possible. I'm going to get out of the way and let you all take over, and I hope you enjoy the program from Mad Science.
Hi, everybody. Welcome today. I am so excited to be here with you. My name is Tubular Todd, and I'm with Mad Science of Central Virginia, and we have got an amazing program for you today. It's really quickly become one of my very favorites because, as you can see from the table, I've got all kinds of stuff set up here. I've got flasks, and I've got beakers, and I've got pitchers and bottles and hot plates and just all kinds of stuff. We're going to do all kinds of amazing things. Some of the things we do today are going to spin. Some of the things we do today are going to go pop. Some of the things we do today are going to go swoosh. And I think we're going to have a really great time. So to get, I came in really early this morning to set all this equipment up, and it really made me work up quite a thirst. And I just kept thinking to myself, I really wish I had, I don't know what your favorite thing to drink is, but sometimes nothing quenches my thirst like a really great glass of juice. And I just kept thinking to myself, why didn't I bring some juice with me? And I was thinking about it and thinking about it and thinking about it. And I thought so hard, I just wish I could make that juice appear. But I'm not a magician, I'm a scientist. So I'll just have to stick with some water for the meantime. And oh my gosh, look at that. It looks like one of my very favorites, cranberry juice. Look at that, or it kind of looks like grape juice. But you saw what I poured it out of, right? I poured it right out of this pitcher. That's amazing. Huh. Well, as delicious as the juice sounds, water really is really healthy for you. So maybe I should just stick to water, I don't know. But we'll, oh my gosh. Look at that. It went right back to water. Now, do you have any ideas how I might have made all that happen? Do you think I just wished it into being? Probably not, right? Because I'm not a wisher. I'm not a professional wisher. I'm a mad scientist. So let me tell you a little bit about how I just made that happen. So before we started today, I got some water in this pitcher, but then I also added a chemical. And that chemical is called phenolphthalein. And then I added some water, but when this glass was empty, and I also added a little chemical called sodium hydroxide. And then in this glass, I had a little tiny bit of a chemical called acetic acid, which a lot of you might know from another name. You might know it as vinegar. And I mixed those different chemicals with the water in different proportions so that it looked like that I had juice and then I had water again, which I think is pretty cool. But one of the biggest things that this demonstration tells me is that it's really important to observe what's going on and not always to trust just what we see. So this is a really good time for me to just mention for everybody who's listening, you saw me make something that looked like water, turn into something that looked like juice, and then back into something that looked like water. But at no time was any of that stuff just water, and in no time was any of that stuff just juice. So we would never want to drink something or eat something if we didn't already know exactly what it was, particularly when we're doing mad science demonstrations, because that way we keep everybody really, really safe. So anyway, I hope you thought that was fun. I think it's kind of fun, but I've got a couple other things now I want to show you that don't involve chemicals, but involve the forces all around us. So this is really, really cool, I think. Also, I'm going to take just a regular little cup. We call these our Mad Science cups. And I've got a platform here. And it's just a little plastic platform with some string tied to it. And what I want to do is I want to see if I can take, well, let me ask, has anybody ever accidentally spilled water on anybody? It's not very fun. Well, sometimes it can be funny after the fact, but when it happens, it's usually not very fun, right? So I'm going to fill this Mad Science cup about halfway up. I've got water, cold water in this bucket here. And I'm going to fill it about halfway up, and I'm going to dry it off with paper towel just so I don't get any water anywhere. Now, if I had other people here in the lab with me, which actually I do, but not right now on camera, I wouldn't want to spill this water on because that wouldn't be fun. But it could be kind of fun. Play with the water on the platform. Now, what I want to do is I want to start spinning this around, and I want to see if I can keep the water in the cup, right? And I'm actually going to step forward a little bit because I don't want to hit the things behind me. So I'm going to be playing with space here. So you might have to bear with me here. let's see if I can't make this go all the way upside down without spilling the water. There you go. So you can see that orange platform is spinning and spinning and spinning. And you might think to yourself, oh my gosh, isn't that water just spilled out all over the place? But you can see, nope, it's still in there. So what kept the water in place? Well, it's a couple of forces. One's called inertia and one's called centripetal force. And you might have heard of inertia. Inertia, generally speaking, is an object in motion tends to stay in motion until it is acted upon in a way to stop it. So basically what that means is once that water starts spinning in a circle, it wants to continue spinning in a circle until there's a reason for it to stop. And then centripetal force is another force which says that objects push on each other when they're in motion, and that helps keep the water inside. So the platform's pushing on the cup's pushing on the water, and that keeps the water moving in a circular pattern, and it keeps the water in place. Now, that can be a fun demonstration, but it also has a practical, real-world application. Now, I don't know if my younger scientists are going to be familiar with this, but if there's any grown-ups watching, you might know what this is. Does anybody know what this is? You might see this if you ever help your grown-ups do the laundry. So this is a little ball that you fill with fabric softener. And then you pull the plug on it tight, and then you throw it in the washing machine. And then in the spin cycle of the washing machine, it pops open and it fills the right amount of fabric softener into the washing. So I don't have fabric softener today, but I do have water, like I said earlier. So I'm going to show you a little bit about how this works. And I'm going to use a little bit more of my water here. And I'm going to pour some water into my fabric softener ball. And it doesn't take a whole lot. In fact, there's little lines on it to tell you how much to put in depending on how much laundry you're doing. I'm going to pretend that I'm doing an extra large load. So I've got the right amount of liquid for an extra large load. And I'm going to pull it tight. Now, I don't know if you've ever seen one of these, but some people use these netted bags to keep some of their laundry from getting damaged. Now, I'm going to spin this around, and we're going to see if those inertial and centripetal forces can help pop that stopper and make the water come out. So there's a very strong chance I'm going to get myself wet, but you know what? That's okay. Let's roll in the name of science. So I don't know if you'll be able to hear this pop or not, but let's be really, really quiet. Listen really, really carefully, and let's see if you hear a little bit of a pop. And when you do, that will be the sound of the stopper coming out of the ball due to those inertial and centripetal forces. So we'll give this a shot. Oh, I just heard it. It was so quiet. I don't think you could probably hear it over your computers, but that plug did go out. Most of the water stayed in right now, which frankly I'm glad of, because when I get wet, I feel it really easily. But in a spin cycle of the washing machine, it would have several minutes to distribute that fabric softener out throughout the entire wash. So that's science in action, which I think is really, really cool. Now I've got another really cool demo for you. And I'm going to need an assistant for this particular one. And I happen to have an assistant right here. And she's going to come over. And what we're going to do, this is called a bungee jump. Now, I don't know if any of you have ever bungee jumped in real life. I have not. It's one of those things that looks kind of interesting, but I'm too big of a chicken to do it. So I'm going to do a scientific bungee jump here using a couple of props. So I've got just a regular dowel here, just a wooden dowel. And this is an Erlenmeyer Flask. And it's kind of a special one because it's got a little arm here that we've run a string through, we've tied it. And then on the other end of it, we have a rubber stopper. And really what we're going to use this rubber stopper for is for its weight more than anything else. So I think the best way to do this is probably like this. Do you think? Okay, so so what we're going to do is we're going to hang the flask, and I'm going to you can't see it because it's out of camera range, but I'm going to take the stopper and I'm going to bring it up to about where my face is. And I'm going to let it go. And I don't know, what do you think is going to happen? Do you think that the flask will crash to the floor and break into a million pieces? I I really hope not. Or do you think it's somehow going to bounce or prevent itself from falling onto the ground with the help of this stopper? So we'll give this a shot. We'll see what happens. Oh my gosh, it did not fall to the ground. In fact, the stopper going in a circular pattern because of the way I released it from my face, it spins around, and instead of just dropping, it wants to continue in that circular pattern like we talked about with those inertial and centripetal forces, and it wrapped all the way around the dowel. So I don't recommend you try this at home without a lot of practice and a lot of soft surfaces, and particularly you don't want to do it with your grown-ups glassware because they might not appreciate that. This glass is, because it's a scientific glass, it's really, really strong, and it takes a little bit more to break it than it would a regular piece of glass. So a cool demonstration, but probably not what I'm going to try at home. So now I've got one of my favorite demonstrations here, and I'm going to, let's see, I think I can get this all into the camera. As you can tell, I needed an extra hand for that demo. And sometimes I think a lot of us say to ourselves, man, I wish I had an extra hand. I could really use an extra hand. And so I think it's time that I made an extra hand for us all. So I'm going to move this out of the way. I've got a ring set up on a post, and I have a latex glove. And so what I'm going to do to make this hand is I'm going to make this hand out of something that you've seen around when you go to the store, when you go, if you ever go out to the lake or anything like that, you might have seen what I'm going to make this out of. But first of all, I'm going to take this latex glove and I'm going to put it on the ring. I'm going to stretch the opening of the glove over the ring. And there it is. So next, I have got two different chemicals. And these chemicals are going to form, actually, I want to make sure that I am safe. So I'm going to put on my protective eye gear. Because if these chemicals got in my eyes, it would not feel good at all. So I'm going to add these two chemicals together. And then we're going to see if we can use those chemicals to give myself an extra hand. So we're going to be creating today a hand that is made out of polyurethane foam. And it's a lot like styrofoam, if you've ever seen styrofoam, which I think most of you probably have. So I have part A here of my chemical mixture. I'm going to pour it in to a cup. And I'm going to put that lid back on very quickly because we don't want that to spill. That would be messy. And I've got part B of my foam mixture. I'm going to pour it into the cup. And let's see if I got about the right amount. I think I got about the right amount. And now I'm going to pour part B into part A. I'm going to mix it up really, really well. And then I'm going to pour it into our latex glove, and we're going to see what happens. So I'm going to pour that all in there. And I've got a little wood craft stick, you might call it a popsicle stick, and I'm going to stir it up really, really well. Now, you might say to yourself that there's no way that this little tiny amount of liquid is going to fill up this latex glove. So my challenge to you is I want you to pay attention to the other activities we're doing, but I also want you to look and see what's happening over here with our latex glove as time goes on. I should get it my thumb. All 5 fingers. Some in the thumb. All right. So right now it doesn't look very impressive, but we're going to check back on this in a little bit. And we're going to keep our eyes on that. And we're going to see if anything changes as those two chemicals react with each other. I can tell you just from feeling it that it's gotten very warm. And when that happens, when you mix chemicals together and you get heat, it's called an exothermic reaction. So we have an exothermic reaction. Actually, you might be able to tell there's actually already expansion happening. So I'll tell you what, I'm going to give this just a moment. I have a little bit of preparation to do for my next demonstration. So while I do that, let's just take a moment and check out this hand. You can really see it. It's filling out all the fingers. It's rising up. It's almost all the way to the wrist line. This might turn out to be the best hand I ever made. So we're gonna let that keep going just for a moment. Now, you may or may not be able to tell depending on what your camera view looks like, but I put some newspaper down underneath it because it's very possible that polyurethane foam mixture might spill out. And so if it does, I don't want it to ruin the tablecloth. So I put some newspaper down. So that's what's going to catch the mess if we have a mess. So I'm going to move some things out of the way, and oh my gosh, it's almost ready to fall over. It's almost ready to pour over the top. It's so exciting. I want to do my other demonstrations, but I'm so fascinated by this hand. I'm going to have so many good uses for this thing. Awesome. Okay. So while that goes ahead and does what we call cure, which means get hard, the soft mixture hardens, we call that a curing process. I'm going to come over to another demonstration here on the other side of the table. So over here, you might have noticed I've got these three colored flasks, or these three flasks with colored water. And that's all it is. It's just water with food coloring. And I've added some yellow food coloring, some red food coloring, and some blue food coloring. And right on the very edge of the camera, you can see this really big flask right here. Now it's got a little tiny bit of water in the bottom. That's all. And I've turned it on so that we can get that water to boil. Now behind it, you saw me dipping into this blue bucket with water, and I'm pulling some ice packs out because it didn't really matter what temperature we had the water for our other demonstrations, but for this one, I want some really, really hot water and some really cool water. So I've got one ice pack, I'm leaving one ice pack in my bucket. And I'm waiting, oh my gosh, this hand is so beautiful. I'm waiting for this water to boil, and you might be able to see the condensation in the flask tells me that it's getting close. And while we do that, I'm just gonna move a couple more things out of our way here. And so what I've got these flasks with the water, you can see I've got three colors, and these are our three primary colors. These are the colors that we make all other colors from. So it's kind of like, I want to see if we can make a rainbow today. So I've got my primary colors, and you can see I've got rubber tubing going from flask to flask to flask. And so our water's almost boiling. And when that water's boiling, I'm going to do two things. I'm going to put the stopper on it, which has its own rubber tube. And then I'm going to take that super hot water and put it into this cold water bath. And when I do that, the hot air inside that flask, which has expanded, the molecules have gotten farther and farther apart, and they're getting more and more excited, they're going to shrink and condense when I put them into the cold water bath. And we're going to see if that change in air pressure can pull water from these different flasks and create some different rainbow colors. Now for this, I'm going to put on my heavy duty gloves because that flask is way too hard or too hot to touch with my bare hands. So I want it, oh my gosh, it's almost there. I think it's probably just about as good as it's going to be. So again, I'm going to take and stopper that bottle. I'm going to put it into the cold water bath. I'm turning my hot plate off, and let's see what happens. All right, now take a look at those beakers and notice that air pressure is changing so rapidly that it's forcing the air to push the liquids from bottle to bottle or from flask to flask to flask. And you might notice some colors change. Now there's nothing going into our yellow, so the yellow is pretty much just staying the same color, although it is getting, the water's going down. But we've gone from, it's a little bit hard to see, but we've gone from a red to an orange in the middle. And then we've gone from an orange to kind of sort of a little violety color there on the end. So I wonder what color we have left in our flask now, in our big flask. So let's take a look. And this is, gotta make sure I have enough tubing. This beautiful kind of indigo color, which is one of the elusive colors. It's hard to find that. It's in the rainbow, but sometimes it's hard to find it in nature. So we've got, or it's almost a kind of a greenish indigo, actually. So we've made our color changes by using air pressure. And again, that air pressure in the, when the flask was on the hot plate, it would expand, 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 expand. When it went into the cold water bath, after I put the stopper on it, it shrunk down. That allowed the air that was in these bottles or these flasks to push down on the liquid and force the liquid into those tubes and cycle through the different flasks to create the different colors. So that's our rainbow maker. Again, I'm gonna just come back to our hand. You can see it's not totally firmed up yet, but it's gotten a lot more solid than it was. It's beautiful. And I wanna make sure, I forgot to put the cap back on my part B of my polyurethane foam, so I'll make sure I do that. So I've got a couple things left for us. And let's see here. Oh, I know. So I don't know if anybody's ever seen a really, really old TV show called I Dream of Genie. If the young scientists have not, maybe your grown-ups have. I saw it now. I'm actually too young to have seen it when it was on TV the first time, when it was originally on, but I've seen reruns over time. Over the rest of my life, I've seen reruns. And it's basically about a man who finds a genie in a bottle. And they live together and they have all kinds of adventures and all that kind of thing. Then she always still goes back to her bottle. She lives in her bottle. Now, you might know a cartoon movie called Aladdin. And there's a pretty popular character in that movie called Genie. Right? And I think in that movie, if I'm not mistaken, Genie doesn't live in a bottle. I think he lives inside a lamp, an oil lamp. But I've got something here today that I want to see. If we can pull a genie out of a bottle. And here's my genie bottle right here. And it's got, let's see what it looks like there. A genie bottle, and I've got a stopper on it, and the stopper's on the top of the bottle to keep the genie in the bottle, right? So I'm gonna pull the stopper out, and it might take a couple moments because some genies are more shy and some genies are more outgoing. I don't know if we have an outgoing genie or a shy genie, but let's take a look and see if we can coax this genie out of the bottle. So let's see what happens. So far, come on. Genie, will you come out? Oh, I think I see him. I think I see him. It's gonna be tough to see. Let me see. I don't know if I've got anything dark here that I can use as a background. I don't think I do. But actually, I do. Thank you. Now, let's see. You can start to see there's some genie smoke coming out of the bottle right there. Let's give our genie just a little bit more time. Wake them up just a little bit more. Now, all you saw me do was pull a stopper off of that genie bottle. And the genie's very slowly waking up and coming out. But I wonder if you have any ideas onto how I got the genie to come out of the bottle, or how I got the genie in the bottle in the first place. So, a couple of questions. First of all, is it really a genie? Of course not, genies are not real. But, oh, you can start to see it. Oh, now the genie's woken up really, really nicely. There we go. So we had a sleepy genie. But the question is, how did we get this kind of a reaction, right? So I don't think I need that black backdrop anymore. because I've got a lot of Genie smoke or Genie steam flying around. So how did I get this to happen? And you might have noticed a couple of clues that might have given you an idea. So first of all, you might have noticed that before I started this activity, I put my goggles back, which might be a clue to you that there's a chemical reaction that could possibly hurt my eyes if the chemicals got into my eyes. Now, a second clue you might have noticed is I put on one of my heavy duty gloves, the same glove that I put on when I wanted to grab this hot boiling water flask a little while ago. So that might be a clue that there's another exothermic reaction happening inside this bottle that would make the bottle hot for me to touch. Now, the plumes that you see coming out of that bottle are actually not smoke, they're actually steam. So here's what was in the bottle before we started. So what I did ahead of time, before we started the workshop today, was I took, and I have one here, it may have got mislocated. Oh, that's right here. No, that's not it. I took just a plain old regular tissue that you might get out of any tissue box, nothing special about it at all. And I laid it on my table. And then onto the table, onto the tissue rather, I poured a tablespoon of a chemical, a black chemical called manganese dioxide. And I don't know if you can see it or not, but it's just a black powder. There you go. And then I took that Kleenex or that tissue and I pulled it up by the corners so that all that manganese dioxide was in a little ball in the middle. And then I twisted it and tied a rope, a little string around it, tied a knot in the string. And then, and you can see, I hung it. Now this is cooled down enough so I can touch it, but it is still, the bottle's still very warm. And I hung it from the neck of the bottle and put the stopper in place to keep the string from falling in. Because in the bottle itself, or in the flask itself, I took a mixture of water and hydrogen peroxide and mixed the two together. Now, some of you might be familiar with hydrogen peroxide because you might have it in your first aid kits, or you might have used it when you got a scrape, or if you want to clean a little bit of a cut or something, your grown-ups might help you put a little bit of hydrogen peroxide on it. But the hydrogen peroxide you use for those kinds of activities is a very weak solution. I was using a science grade solution of 30% hydrogen peroxide, which is much, much, much stronger than what you can buy in a drugstore. Mix that strong hydrogen peroxide with water, put it in the bottom of the flask. And then I added this hanging tissue full of manganese dioxide. Now, I'll pull this out a little bit. You can see how it's gotten all black because that powder was black and it's soaked all through that tissue. So what happens? Hydrogen peroxide, the reason people use hydrogen peroxide to clean wounds is because it helps bring oxygen. It's always letting off oxygen molecules, which is very helpful in the healing and the cleaning process. Now it does that just by itself. So if you went to the drugstore and bought a bottle of hydrogen peroxide, just unscrew the cap and set it on the counter, over time it would be slowly releasing oxygen molecules. But we didn't want to wait that long. So we use a much higher concentrate of hydrogen peroxide, and then we use that manganese dioxide, which we call a catalyst. And that catalyst forces that reaction to happen much, much faster than it would have naturally without our assistance. So the manganese dioxide drops into the hydrogen peroxide and water mixture. It soaks through that tissue, it gets wet, and that creates that exothermic heat-creating reaction. And that's what creates the steam from all that oxygen being released very, very quickly. So not a genie, but to me, a really, really cool scientific experiment and demonstration. So I hope you enjoyed the genie in the bottle. Yeah, it's one of my favorites. And let's see, I think I might have something else here. Oh, I do. I have one more thing. Let's see. I think we're doing pretty well on time. So I've got one more thing for us. And I've got here two small little flasks or beakers. And first of all, before we move forward, I'm going to just take a moment and kind of move some things out of my way. And before I go on with my next demonstration, I just want to see, does anybody have any questions? Anything you want to post in the chat or anything you want to talk about before we move on? Find out if you have anything there. Nope. Okay. So I'm moving some things out of the way so that we can create our final demonstration here. I'm going to put down a garbage bag because this might be a little messy. So the garbage bag will help us clean it up afterwards, just in case. Now, before we do that, I'm going to just take a look at my hand here. I am so proud of this thing. Now, I'm not going to take the time to do it now, but what I'm probably going to need to do, let's see, maybe I can get this. Trying to force the excess. There we go. This is, see, I can use this for high fives. I can use this to shake hands. I can use this for all kinds of things. I'll have to say, I am super, super happy with my polyurethane foam hand. By the way, I should also tell you, polyurethane is something I mentioned earlier that you've seen that maybe in stores or if you go to the lake. Sometimes it's used in things like construction. So they use it sometimes to patch holes in construction of houses or buildings. Sometimes they use it at lakes, marinas. They can use it to patch holes in boats. It's sometimes used as packing material. So sometimes you might get a product that has little packing peanuts in it, and those might be made out of polyurethane foam. So this is a product that's used a lot. And you can see it's nice and hard. Now it's not 100%. There's a little, I can see there's a little bit of space at the very tip of one of the finger, two of the fingers, that hasn't completely gotten cured yet. So I'm gonna not take the latex glove off for a little bit yet. I'm gonna leave that latex glove on so it continues to get a little bit harder. And so let's see, for my last setup here, you guys have had, hopefully you've had a good time. I know I've had a really good time. I've got two little flasks here, and these also have that same 30% hydrogen peroxide mixture that I used before. I didn't put any water in it, it's just that really strong hydrogen peroxide. So I'm gonna again put my eye protection on, just in case. I don't expect anything to happen, but I'm gonna add, we're gonna see if we can finish off today's demonstration with a little bit of a foam factory. So I've got some hydrogen peroxide. I'm gonna add some dish soap, and that dish soap will hopefully, may take that lid off. No, there we go. That dish soap is going to help us get some really nice congealed bubbles so it doesn't just go everywhere. Put a lot of that in. And then I'm going to stir that up a little bit. And just because I think it helps to be seen, I'm going to add some more coloring. And let's see, I'm going to see if I can make a really nice combination of colors here. So I'm going to try 4 of blue and 3 of red. And for the other one, I'm going to try, let's see, 3 of blue and 4 of yellow. Now, you might have thought to yourself, if you've ever helped your grown-ups in the kitchen, it's kind of a nice greenish color. If you've ever helped your grown-ups in the kitchen do any kind of baking or cooking, you might have realized that cooking is a lot like the science that I'm doing today. Because not everything I've done today involves chemistry, But when I've done things like this, where I'm mixing chemicals together, that's chemistry. And cooking, and particularly baking, is chemistry as well. It very much depends on what the percentages, what the ratios are, of how much one ingredient, how much another ingredient. You saw that I had to be sure that I had the right combination, the right volume of ingredients when I mixed the polyurethane foam for our hand. It mattered that I had a certain amount of chemical in for my, this bottle is still very warm, for my Genie in a bottle. I had to have the right amount of manganese dioxide to the right amount of water, hydrogen dioxide, hydrogen peroxide, there we go. And let's see, so I've got my hydrogen peroxide, my dish soap, my food coloring. So I have one more ingredient. And so what I'm going to drop in is I'm going to drop in some potassium iodide. Now this is, again, it's going to be hard for you to see on camera. You can't really see because it's too far into the bottle, but this is actually a white crystal. Actually, I'll tell you what, I'm going to just take a little bit out and pour it in my hand. Now again, I've got a glove on. I would not do this if I didn't have the glove on, because potassium iodide can stain and can cause some skin irritation. So it's just a white crystal. It's the crystal version or the powdered version of what you might know as iodine, which again, sometimes we use in coloring, sometimes we use in first aid, use it to help clean up wounds and scrapes and things like that. So anyway, I've got some of that. I'm gonna pour some potassium iodide into my flasks, and we're gonna see what's gonna happen. Now, I have to tell you, I think I know what's gonna happen, but maybe I'm gonna be right. Maybe I'm gonna be wrong. Maybe I'll be partway right, partway wrong. So we'll find out. So what do you think is gonna happen when I put the potassium iodide into the flasks with the 30% hydrogen peroxide and the dish soap and the food coloring? So let's find out. 1, 2, 3. Pours out all over. I'm so glad I put that garbage bag down. And you can see there's a little bit of the green food coloring and just a teeny bit of the purple, but it really just kind of looks brownish, right? And that's because when potassium iodide is mixed with liquid, it does become sort of a dark reddish brown. It can stain. So it's really a good thing. And that was strong. That was stronger. Yeah. Wow. It's right, Nathan. So that actually was stronger. That reaction was stronger than just the food coloring that I had in there. So I'm really, really glad that I put that garbage bag down first. Now that's also going to make it a lot easier to clean up. So I'm really, really glad that I did that. So I'll tell you what, I hope you guys had a really fun time watching this. I had a lot of fun doing it for you. Again, does anyone have any questions about any of the demonstrations they saw today, or any other questions that I might try to answer, or any of the comments about anything you've seen? An awful lot of this particular demonstration, I would not say you could try at home easily. You're very welcome, Nathan.
I don't have any questions, but I will say that was a lot of fun. And I know that Nathan enjoyed it. He wrote into the comments that he really enjoyed it. It was so much fun. And we really appreciate the time it took to do that. And it's a really interesting program.
Pleasure. Well, that's what I've got for you today. So again, I thank you so much for joining me. Mad Science has all kinds of programs available. And you can certainly go to our website or our Facebook and check out the other programs we have. We also have, thank you, Muhammad, appreciate it, glad you liked it. We can do birthday parties, both at your place and our lab here. And then we can do all kinds of other programs as well. So we encourage you to check out our Facebook page and our web page. And thank you again to the library. It's one of my favorite places to be.
Absolutely. Thank you very much. And everyone have a great day. Enjoy the rest of your day.
Thank you.